Okay.
So this is about hydropower, and it's brought to you by Urban Power U Inc. or UPEC. So classification: hydropower is classified as an inexhaustible resource, and this is due to the fact that the water cycle can provide us with infinite amounts of running water as it's recycled throughout the atmosphere. And we use hydropower, so there's a dam placed in running water, and this dam will funnel water into a little tunnel, which will direct the power into the wind or a little turbine. And as this turbine spins from the water, a generator will spin that's connected to a powerhouse, which translates the energy from kinetic energy in the water to electrical energy that we can use to power our homes, our cities, our businesses. And from here, this powerhouse distributes the power through long-distance power lines to allow us to utilize this energy that has been harnessed from the dam. And the infrastructure requirements are pretty basic. The only real man-made infrastructure that's needed to harness this power is a hydroelectric dam, which looks similar to the diagram on the last page. And but it's ideal for the topography to be something like a canyon or some sort of reservoir where there's a lot of pressure or gravity pulling down on the water, and this allows us to be able to harness more of the force and the energy from the water. And one cool infrastructure development is that if we don't need the water at the current time point, it can be pumped back up to the top of the dam and allow us to reuse this for at a later time. And overall, the hydropower produces 80 to 100 terawatt hours per year, and it accounts for 10% of American energy produced and 20% of that worldwide. And some new emerging technologies is we have smaller scale hydropower plants where it will be something personal, because the cost of upfront is quite large to build these dams in these areas. But by allowing smaller scale projects, we can help harness like the smaller reservoirs and waters and streams, and this can help prove more efficient to small communities. And with digitalization, this can help us with the advancements in AI. It can help us develop like better timing when we're using the energy, and help maximize the output we get by allowing us to find the perfect timing to use water. Like if we don't need it, we don't have to use it now, and it can help us maximize that output. And with nature-friendly solutions, the main downside of this is that it can harm ecosystems with being a large factor in the fish population and just be very detrimental to this. But one solution that has been proposed is these fish ladders, where they will have a small, it's like stepping stones, kind of like stairs, off to the side of a dam where it allows the fish to pass through without being harmed. And then as the fish go through this, the rest of the water is funneled into the power plant. And this, one example of this is the Thompson fish ladder in Montana. And this has saved over 100,000 fish in the past 10 years, and has helped bring back some endangered species that were on the brink of extinction due to the dam's original design. And here's my sources.
All right.